In today's lesson, we're going to learn how to use the quotient rule. The quotient rule is used when we are asked to find the derivative when two functions are being divided. In the general definition, we see that when we have y being divided by, or y equals function f divided by function g, there's a specific pattern we must follow to find the derivative. And the derivative says the following. It is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Now, it seems like a lot of stuff going on there, but if you are consistent in following the pattern accurately, it's not as difficult as it may first seem. In fact, we do have a musical video that I did not perform it, but another young gentleman has, so if my internet loads, I'm not sure how long it's going to take, we will show you this quick video. Okay, I can't listen anymore, but if you want to, you can on your own. But low d high minus high d low, square the bottom, and away we go. So, if we take a look at this function, we are given, it's a quotient of two polynomials, so to find the derivative, capital F of prime, it equals the denominator, which is x cubed plus 1, and it's going to be multiplied by the derivative of the numerator, which would be 2x plus 2 minus my numerator, which is x squared plus 2x minus 3 times the derivative of the denominator, which is 3x squared, and this whole thing is divided by the denominator, the denominator all squared, which in this particular case is going to be x cubed plus 1 all squared. Okay, so we're done calculus right there. The rest is just algebraic simplifying. So f prime, I'm going to multiply these two together, so it's going to be 2x to the fourth plus 2x cubed plus 2x plus 2. I'm going to distribute the negative 3x squared with the negative sign, so it's going to be negative 3x to the fourth minus 6x cubed plus 9x squared, and this is still all over the denominator. And again, you don't need to expand the denominator, you can just leave it as a binomial squared. So now f prime, I'm going to collect like terms. I have a 2x to the fourth and a negative 3x to the fourth, so I'm left with a negative 1x to the fourth. I have a 2x cubed and a negative 6x cubed, so that's negative 4x cubed. I have a 9x squared. I have a plus 2x and a plus 2, and this is all divided by x cubed plus 1 squared. And that's our first example. Now, if we take a look at our second example, again, it's not the calculus in this question, it's the simplifying. So again, before I can take the derivative, I need to rewrite it as a x with a fractional exponent. So now I apply the quotient rule. And again, the quotient rule says I'm taking y prime, so it's the bottom, which is 1 plus 2x times the derivative of the top, which is 1/2 x to the minus 1/2, plus the top, minus the top, so minus the top, which is x to the 1/2, times the derivative of the bottom, and this is all over the denominator squared. Again, we are done calculus here. Now it's a matter of simplifying. So here's what I'm going to do. My first step is I'm going to take this guy right here, and I'm just going to move that negative exponent so that it becomes a positive exponent, but that x can only go down to this 2 here. It cannot go down to the big denominator because it's part of a binomial up top. So to do that, I'm just going to rewrite this as 1 plus 2x all over, if I move this x down to the 2 and multiply it to the denominator here, which is a 1, I'm going to get that. Minus here, I still have 2x to the 1/2, and this whole mess is over 1 plus 2x all squared. Now, we normally don't like having fractions in our numerator, so you notice I have a fraction right here in my numerator. Now, you could get a common denominator, combine the numerators, and then multiply by the reciprocal of the denominator to get your final answer. I kind of like to do a bit of a shortcut here. I want to get rid of this fraction here. So I'm going to multiply every term by 2x to the 1/2. I'm going to multiply that by 2x to the 1/2 and this by 2x to the 1/2 because there's really 3 terms in this expression. So now let's simplify this. So to simplify this, I'm going to have y prime equals, well, in this first term, this is going to cancel out with this, and I'm just left with 1 plus 2x. So 1 plus 2x. Here I have a negative 2 times a 2 is going to give me a negative 4, and x to the 1/2 times x to the 1/2 is just going to give me x. And on the bottom, I can't distribute that into my binomial because of my exponent, so I just write it as is. So it's going to be 2x to the 1/2 times 1 plus 2x all squared. And my last step is I collect like terms in the numerator. So I'm going to get 1 minus 2x is 2x to the 1/2, 1 plus 2x all squared, and that would be your final answer. Now, if you look on the answer key online that Ms. Vigneron has provided for this lesson, I believe she factors out a fractional coefficient and a negative exponent, and then we end up getting the same answer. But I think this way of simplifying might be a little bit easier, but you can check hers out to see which way you like. But maybe we'll do one more of these just to practice. So let's say I have y equals, and let's say I have 2 root x all over x squared minus 3. So again, using the quotient rule, it would be the bottom times the derivative of the top. Well, before I take the derivative of the top, I should probably write it as a fractional exponent. So the derivative of the top, when the 1/2 comes out front, you times the 1/2 by 2, that becomes 1, and then I subtract 1 from the exponent to get x to the negative 1/2 minus the top, which is 2x to the 1/2, times the derivative of the bottom, which is 2x, and this is all over the bottom squared. So again, okay, so now again, we're done calculus, and now we're just going to simplify. So again, this guy right here can be really written as the following. So it's going to be x squared minus 3 times 1 over x to the positive 1/2 minus 2 times 2 here is going to be 4. X to the 1/2 times x to the first would be x to the 3/2. And this is still all over x squared minus 3 all squared. So let me just clean this up here. X squared minus 3 all squared. So now this guy here is just going to slide underneath this here because there's a 1 here. I'm going to multiply those two together. So I'm going to end up getting x squared minus 3 over x to the 1/2. And I'm going to run out of room here, so I am going to go to the next page. Sorry about that. So again, when I multiply these together, I'm going to get x squared minus 3 all over x to the 1/2 minus 4x to the 3/2 all over x squared minus 3 squared. Now, just like before, you could get a common denominator up top, or you could factor out next to the 1/2 if you want. I like to just multiply each term by the x to the 1/2, x to the 1/2, and x to the 1/2. And then here, these are going to cancel, and I'm going to be left with just the x squared minus 3 minus 4 times 1 is 4. 3/2 times 1/2 is 4/2, which is x squared. And the denominator I cannot do anything with. And now I just gather like terms up top. So I'm going to get 1x squared minus 4x squared is negative 3x squared. And this is going to be minus 3 all over x to the 1/2 times x squared minus 3 squared. And if you wanted to really get picky, you could factor a negative 3 out of the numerator to get x squared plus 1 over x to the 1/2 x squared minus 3 squared. And that would be your final answer. So again, we're done calculus right here, and the rest is just algebraic simplifying. Okay, let's take a look at this next question where they're asking us to find the instantaneous rate change. Well, remember, instantaneous rate change is the same thing as derivative. So we have slope of the tangent line, instantaneous rate change, and derivative all mean the same thing. So they want us to find the instantaneous rate change when x is 2, which really means find the derivative when x is 2. So I need to take the derivative of my function. So using the quotient rule, it's x minus 1 times 2x minus the top, which is x squared minus 2, and the derivative of the bottom is 1, all over x minus 1 squared. Now at this point, we don't need to simplify because we're trying to evaluate it at 2. So we're just going to plug in 2 into f prime. So our notation, if I could ever get this pen to work, would be f prime at 2. Now I plug 2 into the derivative, so it's 2 minus 1 times 2 times 2 minus 2 squared minus 2 times 1, which is really irrelevant, all over 2 minus 1 squared. So this becomes 1, that becomes 4, minus, be careful here, 2 squared is 4 minus 2 is 2. My final slope is 2. Or my instantaneous rate change in this case is 2. All right, so if this was a multiple choice question, answer would be right there at D. Okay, last question. I believe we're asked to find the points. Again, we're looking for the points on the curve where the tangent line is parallel to this line. Well, we saw a very similar question in a previous lesson, except now we have to use the quotient rule to find the derivative. So again, the tangent line is parallel, which means it'll have the same slope as this line. but you have to be careful. You have to get that equation in the form y equals mx plus b. So the slope of the line is negative 1/4, which means the slope of my tangent line is also negative 1/4. So now I have to take the derivative, because the derivative will represent the slope of the tangent line. So if I take the derivative, y prime is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom, which that's supposed to be a 1. All divided by the derivative of the bottom, all divided by the denominator squared. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. And if I simplify this, I end up getting, when I distribute the 1, x minus 1 minus x over x minus 1 squared. And if I collect like terms, I end up getting negative 1 over x minus 1 squared. So there's my derivative. And my derivative represents the slope of my tangent line. Well, the slope of my tangent line is 1/4. So those two things both mean the same thing. They have to equal each other. So therefore, I take my slope of negative 1/4, and that has to equal the derivative, which is negative 1 over x minus 1 squared. Now there's a number of ways you can solve this. You could cross multiply and get x minus 1, or the negative of x minus 1 squared equals negative 4. If you divide both sides by a negative, you get that. Now you could expand the left side, bring over the 4 and solve a quadratic, or we can use the square root property, where if I take the square root of both sides, I'm going to get x minus 1. And again, don't forget it's plus or minus because you're solving for a variable x. And if you add that over, you get that. So I get 2x coordinates. X is 3 because 1 plus 2 is 3. Or x is 1 minus 2, which is negative 1. Again, if you look at the question, we're looking for the points. So we have to plug these back into the original equation. So I'm going to plug back into there, which is x over x minus 1, which is going to be 3 over 3 minus 1, which is 3 over 2. So my 1 point is 3 3/2. Or I'm going to plug it in negative 1 in for x to get negative 1 over negative 1 minus 1, which ends up being negative 1 over negative 2, which is 1/2. And there would be my other point. So again, similar questions. Remember, the derivative represents the slope of the tangent line. If they give you the slope, you equate those two things and you solve for your x coordinate. Plug them back into the original function to find y. Okay, that concludes today's lesson. Good luck with the quotient rule.